Picture this. It is the end of the month in an accounts payable department. You've got desks literally piled high with invoices. The clock is relentlessly ticking down, and here is the kicker. For every single document processed manually, that business is bleeding roughly $10 to $20. Ouch, right? But what if you could slash that processing cost to just about $2 an invoice? That's the massive, game-changing promise of a fully automated financial operations pipeline.
So, welcome to The Explainer. Today, we're unpacking a really fascinating blueprint, straight from cracking the AI system design interview. We're going to demystify enterprise AI for finance. And listen, we aren't just talking about building some basic customer service chatbot here. No way. We're talking about building a bulletproof, highly regulated system capable of reading, extracting, and deciding on financial documents. We're talking high stakes with real money on the line. Okay, let's dive right into this.
Here's our roadmap for today. We'll follow the step-by-step journey of a single document through a powerful 5-layer system. We'll cover 1. Fixing financial ops with AI, 2. The extraction confidence game, 3. Deterministic rules over AI, 4. Weighing asymmetric AI risks, and finally, 5. The immutable audit trail.
All right, Section 1. Fixing financial ops with AI.
To fix the whole manual nightmare of financial operations, we really have to start right at the source. Currently, finance analysts spend their entire days manually keying invoices and expenses into an ERP system. They're matching up purchase orders, checking spending policies, and approving or rejecting items one by agonizing one. The volume is just massive, the work is incredibly slow, and honestly, human error under a strict month-end deadline is a serious risk. The goal? We want to auto-decide the clean, routine majority of these items and route only the genuine exceptions to a real human. So the journey begins right here with the document feed. Now, in a perfect world, you'd get a clean, structured data feed straight from another software system that just skips ahead in our pipeline. But let's be real. Most systems have to deal with messy, semi-structured PDF invoices, faded scans, and multi-page receipts just flooding into the queue.
The absolute crucial point here is how we actually handle those messy PDFs. We can't just do a raw text dump. If we just dump the raw text, it's basically like throwing a jigsaw puzzle out of the box. We completely lose all the structural context. Suddenly, the AI has no clue which number is the subtotal, which one's the tax, or which is just a line item. Instead, we absolutely need structure-aware parsing to ingest the text alongside its layout. This preserves those crucial tables and totals so the downstream system can actually make sense of the math.
Moving on to Section 2, the extraction confidence game.
This is where we transition into how the AI extracts all of this incredibly messy data safely, without making really expensive mistakes. This step is the load-bearing stage of our knowledge layer. See, we don't just politely ask the model to read the invoice and write up an open-ended summary. Instead, we heavily constrain the AI. We force it into a strictly typed JSON schema, essentially forcing it to fill out a very rigid digital form. We literally tell it, hey, the vendor must be a string of text, the amount must be a number, the date must be in this specific format. By doing this, we guarantee the output is perfectly shaped for our business logic to consume later on.
Now, you might be wondering, why do we need to be so strict? Well, because AI makes mistakes. Take a look at this. On a complex 55-field invoice task, frontier models actually fail on about 26% of the fields. Just take a second to let that sink in. A 26% failure rate. That is a massive error rate when you consider the stakes here. In financial ops, an extraction error cascades instantly. A misread number in the parse literally becomes a wrong payment going straight out the door.
So, how do we defend against an AI that might, give you a completely different answer every time you ask it? We build a defense against this non-determinism in 3 essential ways. Step 1, as we just discussed, structured output schemas. Step 2, we require field-level confidence signals directly from the model. And step 3, we rely on deterministic policy steps for the actual final decision.
The real secret weapon here is field-level confidence. We don't just want one generic overall thumbs up for the whole invoice. What we want is the AI to tell us, hey, I am 99% sure about this vendor name, but I'm only about 40% sure on this tax amount. That specific, granular, field-level signal is exactly what determines what gets safely auto-approved and what gets flagged and routed to a human for manual review.
Once we finally have our extracted fields, we do what's called a reference match. A field sitting on its own just isn't enough evidence to make a financial decision. We have to check it against the ledger. Is this an approved vendor? Does the total actually match an open purchase order? But the absolute highest value check here, is the duplicate check. By fuzzy matching, which means looking for slight variations or typos, against prior invoices, we can catch identical vendor amount date combinations and stop those really costly double payments dead in their tracks.
Okay, let's look at Section 3, Deterministic Rules over AI. We are now officially in the decision phase, and frankly, this is where we take the baton completely away from the AI. The absolutely crucial point to remember here is that knowable rules must never live in an LLM prompt. Things like spending limits, approver thresholds, non-reimbursable categories, and tax math, those are exact, knowable policies. They must run in exact, auditable code. We want reproducible results that an auditor can actually sit down and read. We literally never want a deterministic business outcome to rely on the random probability of a language model.
Because we've safely placed our business policy inside a deterministic rules engine, it evaluates every applicable rule and forces one of three exact actions. It's either going to cleanly approve the transaction, it'll issue a hard deny based on a clear policy violation, or, if things are just a bit too ambiguous, it's going to trigger the route to human branch.
And that route to human branch, that is your ultimate safety net. Any fuzzy call, any shaky extraction with low confidence, or any sort of matching error immediately lands in a queue for human review. The AI model is strictly reserved for genuinely fuzzy matching. Everything else just falls back to good old human judgment whenever the evidence is even a little bit thin.
Moving right along to Section 4, Weighing Asymmetric AI Risks. Let's shift gears to the evaluation layer for a moment. How do we actually measure if this automated system is succeeding or failing? Listen, if you're only looking at one blended accuracy score for your AI, you are completely flying blind. We have to contrast what we call asymmetric risks. Think about it. A false approve means the AI actually pays a bad or duplicate invoice. That is real money flying out the door and a huge compliance exposure. On the flip side, a false deny just blocks a legitimate payment. Sure, that causes some friction, maybe a delayed vendor, and a bit of analyst rework. But while both are technically errors, they cost the business very, very different amounts.
Think of this whole thing like tuning the dials on a soundboard. You have to set a hard ceiling on your false approve rate to strictly limit any wrongful payments. As you tighten up that threshold, your false deny rate is naturally going to go up, which means sending more items to your human team for review. The resulting straight-through rate, which is just the share of invoices handled with absolutely zero human touch, is simply whatever level of efficiency your strict risk ceiling actually allows you to have.
Finally, we arrive at Section 5, the immutable audit trail.
This brings us to our final compliance phase, how we actually prove the system's actions to regulators. Because, let's face it, in a regulated financial environment, auditability isn't just optional, it is a load-bearing wall. To pull this off, we use something called a hash chain. This is an append-only, write-once, read-many system. Each record carries a cryptographic hash of the record that came right before it. So if anyone tries to quietly alter a past decision, it instantly breaks every single hash that follows it, making any tampering immediately obvious. Think of it kind of like a digital wax seal on every single action the system takes.
We are capturing an incredible level of detail here. Every single record logs the exact decision made, who made it, the exact timestamp, the specific fields extracted along with their confidence scores, and get this, even the specific versions of the policy and the AI model that were used on that particular day. Because of all this data, every single automated decision can be mathematically and logically reconstructed months or even years later for an auditor. It's totally bulletproof.
Through all of this, we also maintain a very strict separation of duties. The fundamental rule is this: the agent proposes, but a human disposes. The AI prepares the data and handles the routine, low-risk approvals based on strict code, but it never, ever moves large sums of money entirely on its own. High-impact paths always require a human to sign off, which perfectly satisfies the 4 eyes principle that auditors expect to see.
So we've seen how keeping AI tightly bounded by schemas, confidence thresholds, and deterministic code makes it incredibly powerful and remarkably safe for high-stakes finance. But it forces us to ask a much larger question about how we implement this technology everywhere else. Look at your own workflows. Where else in your business are you relying on unpredictable AI judgment when you should really be swapping it out for hard, auditable, deterministic rules? Thank you so much for exploring this with me today. I really hope it completely changes how you think about building enterprise AI.